I'm Anil Kumar. Here is a question on factoring polynomials. The question here is, determine the zeros of f of x equals to x to the power of 4 minus 13x squared plus 36. Write characteristics of the function. So we are given the function f of x equals to x to the power of 4 minus 13x squared plus 36. We can treat this as a quadratic function, right? And then we'll follow the same principles which we learn in factoring quadratic functions. So we look for product and sum. We look for product of 36 and sum of minus 13. The two terms could be 9 and 4 when you multiply with 36. Now you need negative these, because when you add you need negative 13. So that becomes the terms which will help us factoring, correct? So we can write this as x squared minus 9 times x squared minus 4. Do you see that? So if you expand, you get the original term. And now we can apply difference of squares. We get x plus 3 times x minus 3, and x squared minus 4 could be written as x plus 2 times x minus 2, right? Okay, so that is the factored form of this function. Now we need to sketch this and write characteristics of this function. So you can write with, let's start with characteristics. One, we can begin with degree. So we have even degree function, right? Now since the leading coefficient is positive, when x approaches negative infinity, y approaches positive infinity, and when x approaches positive infinity, y approaches positive infinity. So both sides are up. We have zeros at x equals to plus minus 3 and plus minus 2, correct? And let's sketch this with these characteristics, and then we can write more characteristics. Is it okay? Right. We'll write domain and range. Range may be slightly difficult, but domain is kind of simpler. We have zeros at plus minus 3 and at plus minus 2, okay? And all zeros are linear, and therefore we can kind of graph this as we can do it like this. So you will notice when you sketch this that the graph has even symmetry. So this function has even symmetry. You can check that f of minus x is equals to f of x, right? All terms are even, correct? That is another reason. So we can check from the graph all these things. Now it has, of course, 4 x-intercepts. The y-intercept will be, when you substitute 0 here, you get 3 times 3 as 9 times 4 as 36, all from this equation. So 36 is your local maximum, right? So we have local maximum at 0, 36, correct? Now it's kind of difficult to find. We can try domain is x belongs to real numbers. So from the graph you could find these minimum points approximately and give your range also. That is, substitute midpoint right here and midpoint here to approximately get the range. So range is above some number which you could calculate, right? So for range I'd like you to calculate these points. That is to say, find what is f of, let's say between 2 and 3 will be minus 2.5. But from the symmetry this has to be same, so we can just find this value. Let's substitute minus 2.5 and find that point. So we have within brackets minus 2.5 x to the power of 4 minus 13 times within bracket minus 2.5 square, and then we'll add 36 to it. to get a term which is minus 45.25, we can say minus 45.25, right? Well, this is not the best way to find, but we can say it is, well, the value is correct, okay? So we can say range is y belongs to real numbers where y is greater than equal to, let's say, minus 45. Right, so we are not getting into this decimal, so approximately, is that okay? So that is how you can also give range. Well, some of you who have done calculus, they can find the derivative of the function and equate it to 0 and then exactly find the value, correct? So we are giving an approximate range, so let's be clear about it, okay? So these are the characteristics. We can say the graph extends from quadrant 2 to quadrant 1, right? Now, these are some characteristics which we can provide. As an added exercise, you can say it is increasing in which interval? It is increasing from this point to this point and from this point onwards. Is it okay? But we're not very sure of these turning points yet. So I'm kind of reluctant in writing these increasing, decreasing intervals. Okay, but it is from increasing from this. So it's increasing here and there, and it is decreasing from minus infinity to that point and that, right? So since we are sure about it, but not exactly, so we are not putting this up, okay? So these are good characteristics to write for the given polynomial in the test. I'll say the best is just to go up to this point, as these things are kind of approximate and it may waste some of your time, which is not worth it unless and until it has been specified in the question. I'm Anil Kumar and I hope that helps. Thank you and all the best.